Hello and good day, everyone. I'm making the short video regarding the circuit called a two's complement converter because in a calculator, when the result is negative, you have to convert the result into two's complement before sending it to a 7-segment display, so that the two's complement into is converted into its normal form, and that people can something that people can read or understand. So creating the two's complement converter is not that difficult because we can build it from a previous circuit which we have created before, a circuit which we call the 4-bit adder and subtractor. Here's the 4-bit adder and subtractor which I've shown you before. The purpose of this circuit is to add or subtract uh, 4 bits A and B, and the result goes into the variable S. So for example, in this case, we know that when sub is high, it will perform subtraction by converting B into one's complement and by adding an extra 1 to the least significant bit. So therefore, in this case, B will be converted into one's complement. Like in this case, if you have 0, 1, 0, the one's complement is 1, 1, 0, 1. And if you add it a 1 for the two's complement, you will have a 1, 1, 0, 0. So how do we convert this into a two's complement converter? The main difference is in the two's complement converter, we only have one set of inputs, which means that we can eliminate A by by uh, replacing it with constant. Before we do that, let's copy this whole circuit and let's create the new circuit called two's complement converter. Okay. And we paste it here. So the main concept here is we will replace our A's, we'll delete our A's, okay, and we will replace it with constants so that they will be always 0. So this is the constant symbol. We'll point it downwards, okay, and then we'll connect it to A. So we don't have to put it upwards anymore because anyway this will be hidden. Then we'll just copy this, put it here. We don't have a label because we will not include it in the circuit anymore. Okay. Copy it again. So now all our A inputs are fixed to be 0. This is, remember, a constant. This is a symbol for a constant. So our A's are now all zeros. Okay. And now we will elevate our B's because this will be our main inputs. Before we proceed, let's save this. So we export this, for example, as two's complement converter. So now we have the two's complement converter, which means that when sub is high, we'll rename this as negative. So we can have a negative input. So this comes from probably a negative sensor from an ALU, which we have created before. So therefore, if the negative input is high, it will convert the input B into two's complement. We can even try this on a circuit by creating a sub-circuit, another circuit. No? So let's have a test, and then we'll insert a sub-circuit. We'll insert the two's complement converter, and then put the necessary inputs. Put the necessary inputs, and then we'll test this against the output. So for example, this should be our B0, and then this is our B1, It's our B2, and we will have our B3 here. Okay, and our input, we'll have it here, or rather output, we'll have it here, our S0 here. Delete this. Make a long story short, we just copy this. Copy this again. We'll find out if we'll have the correct output. We will connect this to S1. And then the third one will connect to S2. And then the last one will connect to S3. And then we'll have one more input. We'll just copy this. We'll call it the negative input. Okay. Here's our negative input. So for example, if you have 1, 0, you have an input which is 1, 0, 1, and the input negative is 1, 2. No, this is connected to 0. It's connected to S1. This is connected to S2. Okay. S2, and this is, let's find out what's wrong. Our S3 is there's a mistake in our S3. Okay, let's try that value here. 1, 0, 1, 0, 1, 0, 1, 0, and then let's do a negative 0, 1, 1, 0. If it's blank, it should be 1, 0, 1, 0. So why is that? Let's check why it's different here. Okay, this is B0, this is B1, this is B2, this is B3. Okay, this is S0, this is S1, this is S2, and this is S3. Okay, let's do that again. Our S3 is wrong. Let's find out in our previous circuit. This is our S3. Okay, it's 1, 0, 1, 0. Let's get this again. B0, this is B1, this is B2, this is B3. Let's just, it's correct, this is correct, this is correct, but this is not correct. Let's find out why. No, we haven't connected the B3 properly. So now it's there. So anyway, when we have our negative input as 0, okay, it will just pass on the input to the output, which means it will not do anything. But when we set this as 1, it will convert it into 2's complement. So you will need this because your converter, or rather your calculator, will sometimes output a 2's complement form. So you connect this to the negative sensor so that it will activate the 2's complement conversion. If the negative sensor is 0, it will not do anything. It will just display the number in its playing form. So I hope you follow. No? You can use this in your project. You can ask me questions. Please post comments, and see you in the succeeding videos. Thanks for now, and bye for now, and thanks for watching.